down there? Great, excellent. Great, okay, good. Well, thanks for that. So I have some material for you today. First of all, to start off with. One is a paper, and so here's a paper to read. And this is a paper written by a guy called Bjorn Hartmann from Stanford University, and he's described something called D-Tools, which is a software package that he developed for rapid prototyping for hardware. And then there's another piece of paper which is from Bug Labs, and we'll talk about Bug Labs a little bit later in the class. This is a, has anybody heard of Bug Labs before? Okay. That's good, so here's some material. So Bug Lab is a hardware platform for rapid prototyping as well. And then the third thing is I have the second assignment for you guys to do. So the second assignment is basically a combination of a hardware-software assignment. So I'll pass it out and I'll describe it and we can make sure I understand it all. So here's the, and I'll put this off on Learn as well. So basically, the idea is to imagine that you're working at a science museum and they want to have you develop an interactive exhibit that teaches people about gravity. And so what you want to do is you want to build a on-screen interface that has a little cannon and a target, and the goal is to be able to tilt the cannon to the correct angle so you can shoot a cannonball out and you can hit the target. So you can imagine this kind of interactive kiosk that has this type of thing. But you're supposed to use some sort of physical input. So the idea is to use processing for the graphics and an Arduino for doing some physical input. So for example, you could have a dial, and as you turn the dial, the cannon goes up and down. You could have a button, and as you push the button, the cannonball launches. You should also allow people to change the weight of the projectile, so it travels heavier, different weighted projectiles. And you should also allow people to change the amount of gravity, and then show that output on the screen as well. So say maybe you'd have a slider bar, and as you slide the slider, gravity changes. So you could say, well, what happens if you are doing this on the moon or on another planet with different gravity, or on Mars? Does that make kind of sense? Yeah. So basically, and there's some options that you could you do this in 3D rather than 2D if you wanted to. You can also have some so they can move the target. So you could have another slider or something so they can move the target along as well. And there's some audio effects, and then showing the path of the projectile too. No, well, you get bonus points for that. So. Yeah, well, if you did just what I said there, you'd probably get a B grade, and if you do the bonus ones, then you'd be in the A range. So go wild and use your imagination.
Will we be able to get extra buttons and stuff?
Yeah, that's for sure. We've got a whole set of them, so it's no problem. Yeah, so that's no problem. Just talk to Michael, and he can provide what you want. Yeah, that could be kind of ambitious, but you'll see how it goes. So and then what you're supposed to deliver is on September the 6th, we'll have demos of the application, so you can see them working, and then provide the executable on the source code of the application. And so you've got a couple of weeks, that's plenty of time. Yeah. So, but of course it's the holidays coming up, starting from next week. So, and during that time, well, you two, and not you so much, will be working on, I guess for Anne, you're working on your thesis, but you're working on thesis outlines too, so you have some time there as well. But I'll also provide a third assignment, which will be set the first week back. And the third assignment will involve more physical prototyping and in particular using 3D printers to print out enclosures and things like that.
Will we be able to print whatever we want, or will it just be...
Well, within the print volume range, yeah. We've got a small 3D printer, so you can't print like a sword or something. But yeah, so that when you get back, we'll have a lecture about 3D printing, and we've got I think the print volume is about 5 inches by 5 inches by about 4 inches. So yeah. So we use the rip wrap we've got here, but yeah, not too bad. $500. So yeah. Anyway, so that's the assignment, and I'll be around the next few weeks anyway. So if you have any questions, let me know how it goes. You can use processing, or if you want, you can use open frameworks. And we'll talk a little bit today, if we get time, about open frameworks. They're basically equivalent, so probably processing is the easiest. But, okay, does that make sense? Is that good?
When do we get the 1 week project?
I need to talk to Christoph. You should get it this week. Because you're supposed to do it during the 2-week holiday as well. So I'll have to talk to Christoph about that. I wasn't sure about what he had in mind for setting on the project. I've got some ideas too, but yeah, that's a good question. And so basically during the holidays, supposed to be spending about a week over those 2 weeks on the 1 week project, and then also putting together a very rough draft of your thesis proposal, and then this assignment. I'm not sure Christoph is giving you assignments, or Andreas giving you assignments as well. But yeah, this shouldn't take too long to do. This is probably 2 days worth of work, I would say. I mean, well, you can do a lot more with it if you add lots of bells and whistles, but yeah. Okay, so let's talk about some lectures. So, okay, so we've been, I just want to do a little recap. It's been a couple of weeks since I saw you guys. So we've been talking about building interactive versions here, and last time I saw you we talked about, we did an overview of a number of different systems. So we talked about paper prototyping, which you know pretty well now. We talked about wireframes, and you did that for the assignment. You can build HTML-based wireframes. And then the last lecture we talked a lot about transitions and about how if you use Flash or another design tool, you can actually focus more on the transitions between screens or the animations, or use animation to show how user input changes things. And then there's interactive prototypes. Using Azure. Has Christoph started talking about Azure yet? Okay, so you've got one assignment, or you've done one assignment already. Okay, great, that's good. How did you find using Azure? Interesting, really? Was it hard to use at Lynn, or is it pretty straightforward?
Pretty straightforward. Some navigation things are just a bit weird, I think, compared to other programs. Just a bit different.
Yeah.
Or just less helpful.
Right, okay, that's good. And what did you do for the assignment?
iPad prototype,
Oh, right, okay. So I guess Azure has a number of templates, and so you just use the iPad template.
You can download widget sets, and those are basically the buttons that you see on the screen.
Yeah.
You can download them for certain.
Okay, and then it produced an HTML output, I suppose, and then you could poke it around there. Okay, that's great. Excellent. So what I want to talk about today a little bit more in detail is the sketch flow. So I was trying to talk about it last time, but we couldn't get the video and everything working because whatever reasons. So I've got a lot more material now. So actually, I've got a presentation about sketch flow. But what I'll do is what I'll do is there's actually a video that is a video of somebody else from Microsoft giving the presentation. So maybe I'll play the video and you can watch that. And then if you missed anything, we can talk about it more in detail. So Sketchflow is this tool Microsoft developed for rapid design. And here's the presentation that I have. So this is from VRail to Para. So I'll just play the video, and he basically goes through all these slides, and then I'll put these slides up on the Learn system as well, so you can download them as well yourself. The video is in my download tool, of course. So here we go.
My name is Harold Trapara. I'm a technical evangelist at Microsoft. Yay, Microsoft. Yeah, I figured as much. But hopefully this presentation will really speak to the designers in the audience, because we have something that's really going to change the way designers and customers who hire agencies will be able to prototype and customers who hire prototype really complex web applications. If we think about how design agencies work these days, even whether you're freelance or whether you're in a big design shop, you typically have a briefing by the customer who gives you a series of requirements. You then go back to the customer after he's briefed you and you rebrief the customer. This is what we think the technologies that could be applied to get your solution up and running. But then what happens is this really annoying phase, and that's called the concept phase. And typically how concept phases are done, whether you're freelance or an agency, is you provide PDF documentations, you provide graphics, sketches, Photoshop images, any type of static imagery, right? And if you really want to go above and beyond, you may have the resources to actually develop a full-fledged Flash prototype or some type of AJAX-type prototype. But what ends up happening is a lot of that is lost because most people don't do the Flash prototype, most people don't code, because in the concept phase, your real job is to win over the customer in terms of design and interaction. And so what ends up happening is, because you're only looking at static imagery and dealing with things that don't have animation.
Okay. They can record from there as well, aren't you? Correct. So this is a tool that's part of the Microsoft Expression Toolkit, and I guess it's kind of a competitor to Azure, but it's has some very nice features, and this has this visual design tool that makes it quite easy to use. So are we all ready now? We'll try again with sound. And I said this is VRAL Tapara giving a presentation, just a 5-minute video.
My name is Harold Trapara. I'm a technical evangelist at Microsoft. Yay, Microsoft. Yeah, I figured as much. But hopefully this presentation will really speak to the designers in the audience, because we have something that's really going to change the way designers and customers who hire agencies will be able to prototype really complex web applications or even rich client applications. And that's using a feature in one of our products called Sketchflow. And we'll get into a little bit. But if we think about how design agencies work these days, even whether you're freelance or whether you're in a big design shop, you typically have a briefing by the customer who gives you a series of requirements. You then go back to the customer after he's briefed you and you rebrief the customer. This is what we think the technologies that could be applied to get your solution up and running. But then what happens is this really annoying phase, and that's called the concept phase. And typically how concept phases are done, whether you're freelance or an agency, is you provide PDF documentations, you provide graphics, sketches.
Let me just pause for a second. So this I'll replay it, but this diagram here is pretty much his version of the interaction design cycle we've been talking about before. So the brief is user needs analysis, and then the concept is what we're talking about here, and then the prototype and delivery, and then it kind of goes around that circle. So it's just the same version of what we've been talking about. But he's going to show how that oftentimes when you are engaged in a project, these bubbles may actually not be equal amount of size or effort, and because of that it may be difficult to produce a good outcome.
Typically how concept phases are done, whether you're freelance or an agency, is you provide PDF documentations, you provide graphics, sketches, Photoshop images, any type of static imagery, right? And if you really want to go above and beyond, you may have the resources to actually develop a full-fledged Flash prototype or some type of AJAX-type prototype. But what ends up happening is a lot of that is lost because most people don't do the Flash prototype, most people don't code, because in the concept phase, your real job is to win over the customer in terms of design and interaction. And so what ends up happening is, because you're only looking at static imagery and dealing with things that don't have animation, don't have the click, the intuitive feel that you would normally interact with in a browser, you deliver something. And when you deliver that application, what tends to happen is, there should really be an arrow going back, but a customer request changes. Now what happens is, you as a designer have to pass on your assets and your entire concept to a web developer, who is then working in whatever your development environment is, from Microsoft world, most people work in Microsoft, work in Visual Studio. So what tends to happen is when a design change happens at the delivery phase, then there's a potential for your entire design environment to completely change. And that's wasted time because there wasn't enough work done in the concept phase. And so if we think about why is it that the concept phase is a nightmare? Well, first and foremost, you get really bad feedback from the customer, especially if they're not design oriented. They don't know, they tend to look at the wrong things because you as a designer, you care about, I want, how should the state of the application be? What pages should I forward to from one page to the next? How should a graphic come in? What kind of animation should be applied to it? What should be the placement of the various UI elements? But an end user, a customer, they'll think, oh, you know what, I don't like that color. I don't like that graphic. I don't like a various load of other things. They focus on the details when they're really trying to get them to focus on the concept. So you're unable to communicate complex ideas. Furthermore, that whole issue I talked about around change. You don't get to really have a full conceptualization stage because you're unable to accommodate for any changes or feedback that may occur. So what you typically do is go straight to the delivery phase. And so you can never keep your customers focused. Words really can't describe what a developer goes through. I go to Picardo facepalm because words, expressing how dumb that was in words just doesn't work. So why is SketchFlow awesome? It allows you to rapidly prototype user interfaces. The applications, whether it's something you've sketched on a piece of paper, scanned in, or whether it's an Illustrator or Adobe Photoshop file, you could actually turn that in just by dragging, dropping controls in the application into a full-fledged Silverlight or WPF application. And first of all, most of all, the feedback system that's native into the whole mechanism is really cool, and I'll show you some of that. And then I'll gloss over some of the other stuff. So what does a SketchFlow interface really look like? Here is a typical SketchFlow interface. You have a whole bunch of UI elements. Now that's using the sketchy style, so it seems like it's been sketched, but it's actually part of the UI, part of the application. Now you could import your own graphics, your own things, but that's what it is. At the bottom, you'll notice that that's your sitemap. That essentially tracks how the navigation between your site will work and how the state between each one of those pages will work. So as you click on each one of those blue boxes, that application will morph, it'll change. So a transition will come in, just like very much a PowerPoint presentation works or any type of state diagram works. That's what that is. And the green bars are elements in your application. And this essentially defines how your application runs. If we look at some of the elements that are really cool in the feedback system is, this is where you can enable feedback, where customers give you feedback, and then if they make a comment on, let's say, the start page or the checkout page, a little bulb pops up, and then you're able to enable that feedback. Well, how does that work? I'll skip a little bit to the front. This is a feedback player that works in the browser. It works cross-browser, Firefox, Safari, IE, Mac or PC, Linux pretty soon, and it runs based on the Silverlight runtime. And I'm out of time, but essentially an end user can run your application in the browser, feedback, scroll, draw, whatever you want, and then you can load that feedback while you develop. And what's really cool is it does a whole development environment for you. And so that's pretty much SketchFlow. You read that. And yeah, done. Yeah.
Sorry? Well, yeah, I'm not sure. So that's kind of a brief overview of what SketchFlow does. So if you're interested in it, I'll put the slides up on Learn, and you can download and you can try it for yourself if you want to play with it. It seems like a nice prototyping tool, which is an alternative to Visual. I mean, there's a bunch of them out there, so that's one possible you can use. The nice thing about it is that it's very easy to capture the end user feedback, as I was saying. So you can, when you publish to a Silverlight executable, and then people can view that inside the browser, and they can provide feedback on the pages while they're viewing the pages as well, which is quite nice. And then the visual design elements are really good. So you can just drag and drop and things like that. So that's all the slides here. I'll put those up on later on, as I said. And then we also talked last week about a lot about using processing as a design tool, and the good thing about processing, of course, is it's got its own authoring environment. There's a large open source community, which means you can get lots of ideas and tools as well, and you can also support lots of interesting interaction types. And there's lots of additional libraries you can download too. And I showed you a demo last week from Toxic Labs of some of what they were doing, which is pretty amazing. So What I want to talk about today, though, is more about hardware prototyping. So, and I know over the last few weeks you've been doing Arduino work, which is one example of hardware prototyping, and I'm going to talk about some other other options as well, and kind of give you more of an overview of the landscape for hardware prototyping. So the basic problem is that as a designer, you may want to be able to rapidly build physical products. So for example, you can imagine somebody says to you, well, I really want a GPS-enabled wireless RFID reader. And so that's combining some pieces of hardware together. And you know, if it's a software system like with the iPad book interface you did for Christoph, it's relatively easy to get a tool like Azure and just draw something and have something working within a couple of days. But with hardware, it's not quite as simple. One of the solutions would be basically to get lots of components and to build something like that. Why is this kind of a bad idea, though? Does anybody have any thoughts about that? Yep, it's a couple of things. It's difficult to, and of course you have to have electrical engineering skills for starters. PCB, yeah. So you have to have the electrical engineering skills to start with, and there are. It turns out that many designers don't have hardware skills, or you know, so that's it can be quite expensive to build these custom solutions like that. So here's a kind of a contrast or a little timeline showing where tools are over the last 40 years or so. So in the 1970s, when you were doing programming, and well, I guess I started programming in the 80s. When I started programming, I did some machine code programming, and it was just a nightmare. It would take you forever to write stuff, and you know, lots and lots of lines of code to get a little square to appear on the screen. That type of stuff. You did the punch card programming? No, I didn't do punch card programming. Not quite that old, but yeah. But there were punch card computers around in use when I was young. But yeah. So so these curves here show that software itself is rapidly developed, and now there are tools like open source tools like Java and Ruby on Rails, things like that, or Flash, for example, that you become very, very productive with a small amount of coding. And it turns out hardware hasn't advanced quite as much. You know, in the 70s you were working with integrated circuits and breadboarding, and today we're still working with integrated circuits. We might have FPGAs, which let you do custom hardware, but it's still a lot of low-level work. So there's some efforts now to try and close the gap and provide different tools for rapid prototyping with hardware. The other issue is that if you want to innovate in consumer electronics, it costs lots of money. So if you want to build a product and bring it to market, it may take up to 2 years or so because of the physical production time, and you may spend millions of dollars, and then you've got this kind of low rate of return. And because of that, it means that people, many times people won't build hardware products because they need, you know, in order to get the return on investment, they need to sell 5 million units or whatever else. So you've got this kind of curve here. This from here on is supposed to be yellow, but so here's today's consumer electronics, which is about a $170 billion market, so it's a very big market. And a lot of those are just a few devices. So cell phones, for example, you know, there'll be 500 million smartphones sold this year, and probably another billion, or some hundreds or 700 million or so dumb phones. Lots of MP3 players, LCDs, and that kind of stuff. So you've got a few products that earn the bulk of this money. But it turns out there's a largely untapped market down here, which is kind of a long tail market, where there are potentially millions of devices that could be made into vertical markets or into more niche markets. But what keeps those devices from being made sometimes is the cost of the production. So, you know, the example I gave before, if somebody wants, for whatever reason, a Wi-Fi enabled GPS RFID reader, there may be only a market globally for that for a few 100,000 units, or maybe 1 million units. And so Samsung or something like that's not going to make a device like that because they need to sell hundreds of millions of units to make it profitable. So, but as an interface designer, there could be a lot of interesting products here. In fact, in many cases, the most interesting products are in this space here. You know, the designing new cell phones isn't that interesting anymore because it's been done to death. So the current approach is that what you do is you do is prototyping phase here, where you build some hardware prototypes, you do some pilot testing, and then there'll be, in this case, just a few units, 2, 3, 4 physical units. Then you'd do some alpha testing, which is hundreds of units, and then you'd beta testing up to thousands of units, and then production where you get to your million units. So it may cost you $100,000 to get up to this stage. 6 months of a hardware engineers and a bunch of equipment and that kind of stuff. And then to get to this stage, it may cost you a couple of $1 million. So it's very different from software development, where software development, if you've got an idea for an iPad app, you go to Azure, you work something up in a week, and then you talk to a coder, a couple of $1,000, he builds it, and you put it on the App Store, and you're good to go. So what we want to do is reduce this cost down. And so, and it's also not just a hardware cost as well, is that the hardware system, you have to provide a fully integrated experience. So once you've got the hardware, you have to also have the some sort of digital interface to software, and you've got to also provide content on the hardware as well, or some data as well. So in building this physical system, you've got to think about how it integrates in with the other pieces as well. So there are a number of hardware prototyping tools that can be used, and these are some of the ones we'll talk about today. I won't touch, well, if we've got time I'll touch a little bit on Arduino, but I think you know that fairly well now. But there's a few tools here, and these tools can basically be divided up in terms of how much expertise it requires to use them versus ease of use versus powerfulness, I guess. So let me show a separate graph here. So here's a little graph showing, hard to read that, but this is the ease of use or the technological ability of the people on this side, and here's the price on this side. So for example, one of the very easiest systems to use is Lego Mindstorms. I guess most of you used Mindstorms before? We've got one here in the lab, a couple in the lab if you want to play with them, but they're essentially visual programming, drag and drop. You don't have to write any code by hand at all. And then, of course, the most difficult is along this side where you've got to write, basically be a custom IC. So here's Mindstorms. Unfortunately, they're quite expensive. So if you go down to buy Mindstorms kit, I think the price in New Zealand is about $400. Do you know, Michael? What's the price? Yeah, I think the new one's about $400, and it's about $250 US for essentially a microcontroller with a bunch of sensors and some Legos. They are really cool. That's true. Yeah, they're really cool. So they're expensive, but they're very user friendly. And so if you've got a 9-year-old kid, they can use Mindstorms. It's great. And then you've got things like Arduino, which is actually sufficient for most prototyping needs. I guess you know the system pretty well now. But the price is the Arduino boards are around $40 or so. So it's not a chip. And then you've got the chips and PCBs. So the raw chips can be relatively or very inexpensive, but you have to have a lot of programming ability to be able to program these. And so here's some rough costs. So Mindstorms, I guess, this is in euros, so €250. The Arduino, €25, and an integrated circuit, €4. So it's almost an order of magnitude difference between each of those three there as well. Sorry? Oh, really?
Setting up all the pins and stuff.
Yeah. How was that?
Yeah, it was interesting. Effectively, wired into a circuit board and electrical and all that stuff.
And of course, there's also not just the cost, it's also the time as well. So when you program the app Mega, I guess if you did the same project on Arduino, it probably would have taken less time.
We basically did a scrolling message on a 5x7 LED array.
Oh, nice. Cool. Very cool. So that's kind of shows the. So now let me talk a little bit about what Bug Labs does. So Bug Labs, and I've got their show you the website. It's still up. Oh, nice. So all the excellent. Okay. So all the tabs I had. Bug Labs, no, it's a company. But yeah, all the tabs I had nicely set up. Yeah, it's not a big company, so Mike might be this one sales guy. So let me go back and find Bug Labs. It's like I lost all my links, which is really annoying. Okay, so here's the Bug Labs website, and so So basically what Bug Labs is, it's a modular hardware system that you plug modules together and build prototypes with very little development. So let me give you a little bit of background on the company first, and then I'll relatively, yeah. I mean, so they were founded in 2006. They're still alive. They've got 20 or so employees. They won a prize at the CES for the best technology. So the basic idea with Bug Labs is that you can now move this line. So previously, you would have to do the pilot testing with custom hardware, and that would be where you start spending your money. But now with the Bug Labs, you can do all the way up to alpha testing with Bug Labs hardware, and it also reduces the time. So instead of, if I go back to the previous, I should have arranged them differently, but the this one here. So previously, the prototyping would take between 2 and 6 months, and then you'd build an alpha prototype, which would take another 4 to 6 months, and then you start doing the production, which would take 12 months later. So the idea with the Bug Labs is that you can move that line, and so now the whole up to alpha stage just takes 1 month, and it'll cost maybe $10,000 to $50,000 as opposed to $100,000 to build the pilot, plus another $100K or so to build the alpha version. So it reduces the cost quite substantially. No, we don't yet, but we'll get some. So they basically have this 3-tiered system where you've got these physical modules, you've got this digital interface, and you've got this content interface. So let me show a video, and I'll show some of the physical models, and I'll show you on their website what they've got. And then you can see from there. So where is my video player? Okay. So this is the, I've got 2 videos actually. This is the one from the
All right, check it out. Now we're at Bug Labs. You may have heard of these folks before. They make the sort of modular gadget. You can put together all of the pieces. It's the build your own gadget folks. And I'm sitting here next to Alicia, who's the gadget wrangler. That's
Hi.
really your title too, isn't it?
It really is actually my title.
Yeah, that's very cool. So tell me about what we have going on with Bug Labs right now. What are you holding on to here?
What I'm holding on to is a bug. It is a fully programmable Linux base where you can stick 4 modules in, any 4 of your choice. I have a camera module on, I've got an accelerometer motion sensor, and I've got a touchscreen LCD. So what I can do with this application is I can take your picture right here, and it renders that to the screen. Here's the camera. And then I can make it say things like bug rules, I can draw on it, I could write who you are, things like that. And then I can upload it to the web, just like that.
That's cool. Now, what are some of the? Give me an idea of some of the various configurations that you've seen of all this stuff. Because I see all these different pieces, and let's say you're sort of not a total novice, but you're not a programmer. Are you still going to be able to use this and put together some cool stuff?
Well, currently our audience is Java programmers.
Okay.
Basically, we are very young. We're only about 2 years old, and we just started shipping a couple months ago. So we're really growing our community right now, and we need a lot more apps before it becomes something that that my mom can pick up. And
Right. So once the community starts really getting their stuff out there, It's going to be a lot easier for the more novice people to put a few pieces together, install the app, and get off running.
Yeah, and one of the really interesting apps that I've seen is, we're from New York.
Okay.
And so we take the train to work every day, and somebody wanted an application that would wake them up when they got to a particular stop. So they needed a GPS alarm clock. That kind of thing does not exist on the market. You cannot go buy it. And that person didn't know how to, acid bath circuit boards and solder stuff together and program their own chips. So what they did is they took the GPS module and the audio module, attached it to a bug base, and wrote an application to wake them up when they got to Penn Station, rather than at 8 o'clock when they may or may not have missed their stop already.
That's very cool. Do you have a module that'll shock you or something?
We should have a module that would shock us.
Yeah, a shocker module. Yeah, that'd be cool.
But we could make one out of the von Hippel module, which is named after Dr. Eric von Hippel of
Okay.
MIT. He wrote the book Democratizing Innovation, which is what Bug is trying to do.
Right on.
And so this is our von Hippel module, but it's a breakout board with general inputs and outputs. It's got serial interface. It's also got USB.
Well, so this will allow for some serious hacking.
Absolutely,
All right.
it's a hardware hacker's dream.
Right on.
And so we could, definitely put something in here.
Look it up some
which
electrodes
would
in a
show-
car battery.
Absolutely.
Yeah, all right. I like this. I like where this Bug Lab stuff is going. So, all right, so what are the different modules that are available on the market right now?
Sure.
Like if somebody's watching this, they're lusting after, like, man, I got to get one of
Yep.
these. What are the
You can
different
go
pieces?
To, buglabs.net/store
Okay.
to buy the product, and the base is available. The camera module, the touchscreen LCD, the accelerometer motion sensor,
The Von Hippel?
the von Hippel module, and the GPS module.
Okay.
Those are all available. The audio module will be coming out extremely soon, in the next couple of weeks.
And I see this antenna. I see one with an antenna here.
Yep, that is our 3G module.
Oh, cool. That's
so-
going to open up a lot
Yeah.
of really cool possibilities.
We announced a few new modules right here at CES, but they're not actually available yet. We're still working on the plastics and things like that. So those new ones include the G3 module, the Zigbee module, the Wi-Fi Bluetooth module, the mini QWERTY keyboard module, and this right here is our mini projector module. You can see it's displaying this image, and this is outside of the plastics right now.
This is really impressive. All right, so you told me the idea of the GPS activated alarm was really, really cool. Give me one more application you've seen that you think was just really, really creative and interesting.
Okay, so let's say that you want some sort of home security system. Maybe you're even only 7 years old and you want to see when your sister's going in your room, something
Sure.
like that. You can take the bug base, hook up the motion sensor accelerometer, the camera, and the Wi-Fi, and you can have the camera take a picture whenever motion is sensed, and then zip that to your Twitter feed, and you know.
I need that to keep an eye on my dog. So
Right,
I have two dogs, and when there's trash on the floor, I never know who to blame. So I have to punish them both brutally and
Right.
equally. And if I knew which one it was, then I'd know which one I have to put out in the cold for 2 days.
You've got a similar problem as my brother. He's a fly fisherman. He makes flies. The cats jump on the desk while he's at work. For a while, he was putting a webcam up and hooking up an old telephone and calling home
Okay.
whenever that happened. But then he had to sit at work watching the webcam all day. Huge problem. With this, you wouldn't have to do
This
that.
could potentially save one of my dogs a lot of pain and suffering. Well, all right, hey, thank you very much, Alicia. I appreciate it. Bug Labs, check them out.
So that's Bug Labs, and then so as I said there's lots of different. This is a little old video. This is from 2 years ago. So now they've expanded their devices and everything. So you basically go to their store, and they have lots of different components that you can buy. If I can just scroll my thing down here. They're kind of expensive though, so that's why we don't have System in the lab. But basically, you can buy the so for $1,600 US, you can buy the professional high performance bundle. I'm not quite sure what that means, but if we click on that, we'll find out. So this has no information. Where is it? You see? Okay. Let's see what that is. So this is kind of a starter kit. So it's kind of expensive, but when you look at the cost of that versus the cost of a hardware engineer for 6 months and everything, then maybe it's worth it. So while it's downloading, you can see. So that's the. You have to have that base module, which is this one here, to get started with, and then you can buy other different things. So here's the GPS module. But still, I've got no idea what that is. The I guess it's 3G or CDMA. Here's the camera module. I guess there's more than 10. So 50 results. Let's see if there's more. Because she was USB module, telemetry. There's the Von Hippel she was talking about. The US power supply. There's a GSM kit, health extender. I don't know what that is, but like they're not in stock. So here's the base kit that provides you with, looks like there's a VGA output. Yeah. CPU, which is the LCD, the video, the stinger, which is docking station, I guess, GPS, the camera, the wonderful module, the USB, so pretty much all of those. The micro projector was kind of cool, but I don't see that for sale anymore, so maybe they don't have that. But I presume you could plug the docking station in here and put a projector on there as well.
Still being made because there's that widget number 2 at the bottom, which is HITD601.
Yeah, well, so some of the pieces are made. Anyway, that gives you an idea of what the hardware platform's like. And so, yeah, so it's about, I guess, 2,000 New Zealand dollars or so to get started. And then, slides, in addition to the hardware, they've got their software platform as well. So as I was saying before, you need to have this whole fully integrated experience. So the bug system's just on the left-hand side. Then you have the bug hardware. It's also open source as well, so potentially people can make their own modules that sit in there as well. Here's different modules they've got. They list a projector, but anyway. And then they have this Dragonfly IDE, which is a developer's kit that lets you drag and drop components to build the hardware or build the systems. Also, it's quite cool because it also integrates in the community feedback here as well. So it has a kind of a discussion board thing that you can log into at the same time as well. And then you've got BugNet, which is a content interface. So you can go out and you can see applications other people have built and share them as well. So if we go back to the not that one. Not that one either. Where's my okay? So if we go back to their page here, then you can see there's a support page which has a link to their community, and so here's the forums which you can go on to, and you can see. Oh, actually, I missed it. There's at the bottom there's a link for the apps people have made. So stuff there, and then that's and I think the test kitchen is where they put their apps, the projects. So here's different projects that have been done with Bug Labs, so some sort of mini module and things like that. So, and
If you click on bug systems, it'll tell you all the modules are on this end.
let's find out. Good idea. No, not really. Maybe developer resources, I'm not sure. Yeah. Okay. Anyway, so I don't want to spend too much time on that, but the other interesting thing is their framework they use. They use a Java framework using the OSGI system. And what this means is that all the hardware functions are represented as services that you can connect to over the web as well. So you can have, oh, I left out a slide. Oh, okay, so there was another slide I had that was showing a set of modules, and each module had its own IP address. And if you want to, you connect via the web to the module, and then you get the data through the web over the IP address as well. So if you want to stream video from the camera module over to your web browser, you can do that. So here's a couple of examples of how that might be used. So this is one example for remote healthcare. So the idea is that the doctors have to fill in forms, and they use this Anoto pen. Are you guys familiar with Anoto at all? So Anoto is a pen with a camera in it, and as you write on special paper, it'll capture your strokes and store them in the pen. But it also has a Bluetooth module, so you can basically write on paper, and then you can Bluetooth the data over to a Bluetooth receiver. And so this, what you could use is use the Bug Labs here to capture the Bluetooth data from the Anoto pen and then send it via the web to some remote server. So this is being used as a small portable transmission device. Another idea would be for real-time content sharing. So here's a woman with a camera, and she takes a picture with her mobile phone, and then you can use the Bug Labs to use Bluetooth to send that picture from the phone to a remote picture frame. And so in near real time, you can be taking pictures and uploading them to the picture frame wherever your mother or father is or whatever, so they can see the holiday snaps as you're doing them. So that's the Bug Labs, and I want to talk about also the DTools as well, which is this paper that I gave you. And DTools is a really interesting system because it, in some ways, it's richer than what Bug Labs provides because they have a very nice visual design interface. And you can see it on the second page of the paper. I'll just load up the DTools page. And I don't think that's the website. Yeah. And let's go find this page. And where is DTools? Here we go. So this is older, and this came out of the Stanford University, and they basically, oh, this is going to work. I was trying to get the presentation before I couldn't find it, but anyway. They came out of Stanford University, and they wanted out of their design school, they wanted a tool that would allow designers to rapidly build physical prototypes without having to do a lot of soldering and low-level programming. So in some ways, it's a competitor to Bug Labs, but the way they designed it, it actually works with different types of hardware. So they have their own hardware, but they also have a version that works with Arduino and with other hardware devices as well. So it's kind of hardware agnostic. So basically, what you have is this editor, and the editor uses a visual programming. You can design a user interface on the editor. You can drag and drop properties and connect them visually, and then you can play and run it. And then when you run it, it'll you can either run it on a simulator on the screen, or you can connect to the hardware platform, and you can run on the hardware as well. So let me show you the video of this thing working. I don't have any slides for it. I was hoping to get slides from his site, but the slides didn't work. But you can read the paper here as well and get a good description also. So let's see the video, which is here.
This video introduces DTools, a tool that enables rapid and reflective prototyping of physical user interfaces.
So
As computing
what he just said is rapid and reflective prototyping. So the idea is that you should be able to do with hardware just the same as what you do with processing or software. So oftentimes with software, you'll make a change and you'll run it right away, and then you think about it and make another change. And with hardware, traditionally in the past, it's been pretty hard to do that because you can't move a resistor on a circuit board and then it takes a few minutes to solder it and retest it, and it takes a long time. So they want to be able to have a tool that would let you do the same thing, is that you should be able to rapidly build something and make the changes right away. So
a tool that enables rapid and reflective prototyping of physical user interfaces. As computing leaves our desktops and enters our world, the number of user interfaces with novel physical form factors and advanced sensor input is growing quickly. DTools is the first system that offers integrated support for designing, testing, and analyzing early prototypes that bridge the worlds of bits and atoms. The following scenario shows how designers can rapidly build and evaluate with DTools. Sam is an interaction designer who wants to create a novel map navigation interface for a handheld GPS device based on orientation sensors. He connects a small LCD screen for display and an accelerometer to the DTools hardware interface kit. As he plugs in physical components, virtual counterparts appear in the DTools authoring environment on his PC. Sam then authors interactions by creating visual states, which encapsulate output, and linking them through transitions, which get triggered by hardware input events. In this example, Sam is authoring map zooming.
So you can see they're also focusing on the transitions, just like we talked about with Flash before as well. So, but in this case, you can set up hardware transitions and then run them on the device as well. So
button presses. To help his work with analog sensors, Sam can author transitions by demonstrating them in physical space. Here he is setting thresholds for an accelerometer by tilting it and setting limits in the live data view using the keyboard. At any point, he can try out his interaction model by using the attached hardware inputs, or by simulating such hardware input on the PC. After trying out some initial interaction ideas, Sam designs a more durable prototype to test different interactions with office mates and users. To increase the realism of the test, he asked Jim, a programmer in his office, to add navigation of a live map database. Jim attaches a few lines of Java to different states in order to remote control the Google Maps application. This is an example of how DTools can be used to create mashup prototypes, an approach that is becoming increasingly common. In test mode, DTools records all user interactions with a prototype, simultaneously recording a time-synchronized video stream of the user's interaction with the device. The video is automatically structured through state transitions and input events. During the test, the designer can also annotate segments of the video for later review. Switching from test to analyze mode, Sam sees an overview of the interaction model during the last test. This aggregate view shows which transitions were taken most frequently and which ones were never reached during the test. In Analyze mode, the state chart is synchronized with the video interface, allowing our designers to replay the user's interactions in parallel with the video, visualize timeline events as they appear in the state chart, and quickly jump to video of particular states both through the state chart and through the physical prototype. Multiple categories can be selected, allowing a designer to pinpoint a particular interaction by replaying it on the device. Multiple test sessions can be combined into a video spreadsheet, which can be used for rapid, comparative evaluation. Individual clips can be played simultaneously. Clips can also be triggered by clicking on the corresponding event on the timeline. Additionally, clicking on a column plays a single category for comparison across all users. We employed 3 different methods to understand the interaction and architectural approaches embodied in DTools. We evaluated the threshold with a first use study with 13 participants, the ceiling through rebuilding prototypes for existing and emerging devices, and naturalistic use through longitudinal deployment in an HCI class. Projects built with DTools by students and authors include a digital camera interface with a large number of buttons to navigate images and menus on a color LCD screen, a sensing PDA that can detect portrait and landscape mode, scroll by tilting the device, and plays voice memos when held up to the face, a color mixing interface where children can pour color from tangible buckets onto an LCD screen and then use that color in a painting application. Tangible drawers that offer access to personal data on an interactive multi-user table. We have released DTools to the design community as open source.
sorry? That was 2006. Yeah, I mean the tilting. Obviously, that's what you do with the iPhone now. But somebody had to prototype or design that kind of idea. So that's. But anyway, so this tool is available now as an open source tool, and so if you go to the well, let's have a look. That's not a good start. It's actually this credit here. Well, the main author Bjorn has left from there, and he's now working at Berkeley University. But let's see here. Yeah, so here's the software, and the source code you could here we go. Yeah, so it's a few years old now. And 6 downloads this week, so you can look at the number of downloads and you can change it from 2006. Well, it's only had 6 downloads, so it's we had 3 from China. But let's see the whole history of downloads. So see, it's I would say it's dying out, but you know, but quite popular. The beginning. Yes, this is. I guess this is by month probably. So not a huge number of downloads. So 4,000 downloads over time, but it still could be a useful tool anyway. And in the lab here, maybe over the summer we might try and get D-tools working. And because if it works with the Arduino platform, then you can. Previously they had their own hardware platform they would use, but what I particularly like is the not just the design tool, which is really good, but the analysis tool. So it was really great how you could record what people were doing with the hardware, and then you could also use that for evaluation and play back the recordings as well. So that was really cool, and that's quite unusual to find in a prototyping tool. Most prototyping tools will let you prototype, but they won't let you run user studies within the tool as well. Anyway, so that's D-tools. Bjorn, that was his PhD thesis. Well, one part of it, he wanted a tool that let him build lots of different devices, and he decided instead of spending hours and hours building the individual devices, if he built an authoring tool, then he could get other people to build the devices as well. Do it that way. So the other, I want to talk about 2 other tools as well, and then we'll change topics a little bit. We'll go back to the rapid prototyping slide. Let's see here. So there's also NetDuino. Do you guys know NetDuino? Okay, so NetDuino is the Microsoft platform, which is effectively it's a competitor to Arduino, and it lets you program using C#. Yeah. So here it is. Here it's an open source hardware platform that uses the .NET framework, and also relatively cheap, $35 for the base hardware, and then they have a microcontroller that doesn't have with Arduino. There's lots of different form factors. I guess you guys know that you get the small ones, big ones. It just has a single board, but it's very, very easy to use. So the I don't think they have here. The basic Hello World application is let's see if it's on here. Is a camera application. Yeah. So the Hello World application is a camera application that lets you take a snapshot and then see the snapshot on an LCD, and then also use the orientation somehow to navigate through the snapshots. But to do that, only needs about 10 lines of code. So the code is very small. Okay. Yeah. See if I've got. They had a the base. Oh, okay. If you can. Okay. To order through here. You can buy these base kits that have a whole bunch of different seed stuff there. I've got a video I can show as well. So let's see. Let's look at that. Here we go. So here's a small tutorial video that.
This is Human Hard Drive, and today we're starting out our microcontroller tutorial with the NetDuino. So here it is. This is the NetDuino. This is This is a .NET framework microcontroller, which means that it runs with the Windows operating system using the C# language. This isn't the first of the .NET framework as compared to this, the Fez, which we'll talk about later. It's running an ARM7 processor. This is actually an ARM processor, a very powerful microprocessor. 48 megahertz, capable of multitasking. This is the base model of the NetDuino as compared to the NetDuino Plus and the NetDuino Mini. As compared to the NetDuino Plus, there's no Ethernet port or microSD slot, and the NetDuino Mini, which is base stamp pin compatible. You might notice that the pins are odd and they look somewhat familiar. This is actually Arduino compatible, which means you can take an Arduino shield, video game shield here. You can take it and it plugs in just like it would on an Arduino, and the pin
You
is.
guys know about Arduino shields, don't you? Yeah, so you know about Arduino shields? Okay, I've got some slides about that. So basically, with a base Arduino, if you want to enhance capability, you can add more daughter boards on top of it, and you can add behaviors. So this pin combination here, the blue pins, are the same combination as the Arduino shield. And I'll show some slides about it in a second.
Mapping is almost exactly the same. So, like the Arduino, you've got your 14 digital IOs, your 5, or 6 actually, analog to digital converters, and your other pins. You've got your DC jack, which takes up to 12 volts and will convert it to this, but it can also be run off the micro USB port. So it's actually quite a powerful little microprocessor. It's got the built-in switch, so you can actually start running. It's got a built-in switch and built-in LED, so you can actually start running programs right away. So there you have it. This has been an introduction to the NetDuino microcontroller. Check out further videos where I'm going to show you how to use this thing.
This is the base hardware there. And as you see, the cost for that is relatively inexpensive. So let's look at Amazon, and they've got $35, and then there are also other. It's open source, so that the Arduino group probably don't care. So, yeah. Well, you can make profit from open source by selling services and stuff. So, yeah. So then they've got other things as well. These other boards you can buy as well. So here's a, yeah. So, and so if you're, yeah, I mean that's the same as the iPhone 3s. Yeah. So it's more powerful than the it's more powerful than the Arduino, but it doesn't have such a big community behind it. So, yeah. The other tool, which is some people use, so the Arduino and NetDuino both require a similar level of skill, in that you pretty much have to be able to write some code. The DTools and Bug Labs don't require much in the way of coding ability. The other one, which I didn't have a slide for, is the Fidgets. And Fidgets is a physical programming. Yeah. Yeah, so here's Fidgets here. So these are products for USB sensing control. So they're basically plug and play building blocks for building USB controlled devices. They came out before Arduino, and I guess they probably got a smaller user community, and they're more expensive, I would say. Yeah. Yeah, but they do some different things, so they can actually they can have actuators, things like that. So if we go to the well, I've got a small video showing some fidget use in use. So here's little fidget demo. What they have here is they have it's a Wiimote, and it turns the Wiimote around and using the rotation of the Wiimote to change the screen here. It's really annoying, but yeah. So this real cube or box is hooked up to a fidget with a motor, and then he's using the motor to control the fidget as well. So that's the type of thing you can do. The costs, though, let's see if we can. Where's the? If we go to the cart, they'll show us. No. Dealers. Where did they go to here? Here we go. So basically, you start out with one of these I/O boards, or the fidget interface kit. So it's about $100 US, and then you don't need to do any soldering. They all have these USB connectors that you can plug in. So and then you start buying different sensors. So here's a analog sensor, so it's $50 for that. Here's some other different types of sensors. Touch sensor, GPS sensor, temperature sensor, all these different stuff. I guess one good thing about the fidgets is that they have a very large range of different types of sensors that you can plug in as well. So it's expensive, but it can be good for prototyping because then they've got this range of different motors as well. So you've got a motor controller here for $80, and then you've got different servo motor kits you can plug into here. Sorry? Yeah, stepper motors. And, yeah, so there's a bunch of stuff there as well. It's older, and the programming is about the same as programming and processing. Yeah, so they Python and different things like that, and then they can also do some stuff in Java and iOS, although not as well supported, and there's a bunch of other languages too. Great, and so the last thing I wanted to do was to just talk about Arduino a bit more. I've got a big presentation for a guy made for Arduino, but I want to just jump through a little bit so that yeah, it's this one here. So we can cover up a few gaps you may have from what you've done already. So this is a presentation that a guy from Taiwan made, and let's just zip through really quickly. Yeah, yeah. Depending how they do the dates. Yeah, it's a month ago. Yeah, yeah, definitely. So I think you all know the basis of Arduino programming, but what I wanted to talk about was the different variety of Arduinos that are available. So here's the different sizes. I guess in the lab we've been pretty much using this one. Yeah. Yeah, it does. Big square one. Yeah. Have you? So you use a Nano, have you? Oh, okay. Yeah. So and then they have these other ones, like LilyPad, which is designed for clothing. So they have these lots of hooks here where you can tie in conductive thread, and then you've got these other ones. The Cortex will be very powerful when it comes out. Yeah. So here's all the different compatible devices. Lots of clones. So then we have these Arduino shields, which are basically a daughter board you can add on to add more capabilities. So here's an Ethernet shield. You plug it in now. You've got an Ethernet port, and you stack them on top of the Arduino. They just pass through. Yeah, I'm not sure programming-wise how you access it, but anyway, maybe it becomes like a bus, and you just know that this provides Ethernet capability. So there's other shields you can get, like an input shield here, driving for motors. Here's a touch screen here, SD card, other vibrators devices.
Some of those, but I've never called them shields.
Yeah. Lots of sensors, so it's very, very flexible and powerful. And well, I won't talk about. Well, here's a few applications. So this is the lily pad being used with to provide turn signals on a jacket. Because if you're biking, maybe that's good. It's a heart rate monitor, USB business card reader, and so forth. This is kind of interesting. This is a visual programming language for Arduino, so it's using the Scratch interface. Yeah, it's a bit like Mindstorms. So
They teach Scratch at the Polytech.
right.
My ex was doing an IT course, and this was the first language they taught.
Yeah, it's a great language to learn programming. I mean, it's good. Then you can go from that to Java or some non-visual programming tools. But this is great for kids, though, and so forth. So that's kind of Arduino. Is there anything else which is relevant? Lots of projects, and yeah, I guess you know that they've got Arduino works with Android as well, so you can have a developer kit that uses the phone hardware for sensing and then uses Bluetooth to Bluetooth over to the Arduino board and then control things and things like that.
Raoul did something similar to that. He lost his motion sensor, so he plugged in his phone into it.
Yeah, yeah. So, okay, cool. So that's all I want to do for hardware. Let's take a short break because we've been talking for a long time. And then come back in like 4 or 5 minutes, and we'll start talking about some new software libraries. Oh, first of all, does anybody have any questions about this at all, or it doesn't? Well, actually, Arduino drives the MakerBot. So in the MakerBot hardware, the what drives the motors here in the printer is a set of Arduino boards. Yeah. Two color heads. So when I was at SIGGRAPH last week, they had people doing 2-color printing as well. But yeah, Arduino drives this. It's not.
You should buy some more awesome colours from PLA.
Yeah, true.
There's a place in New Zealand that sells it relatively cheap as well.
Does it sell MakerBots or?
No, sell PLA.
Oh, okay.
It's because the stuff you've got there is from the US. So
Yeah.
you can run it back in New Zealand.
Sure.
where
Yeah.
it's
Cheaper.
cheaper.
Of course. Yeah.
Then you can also get awesome colours rather than just clear.
Yeah, that's true. Well, the idea is you paint those afterwards, hopefully. Oh, so you lost the audio recording. Well, it's it's not. I don't think it's that important to record all the lectures. I mean, I think it's good to get one of each lecture that's really good, but probably in 2 years' time or so we'll have all the lecture material down pat, so it becomes very smooth and well done.
Yeah, you have the same lectures for the ones who started in February, right?
Yeah, but I guess
It's a little different. So the material was changed a little bit, and I'm still making changes. So it's probably going to be next semester or semester after where we've actually got it solid. Yeah, it takes a little while.
these things change as well.
Yeah, we'll have to update every year, but some of the principles don't change, but the technology changes a lot. So yeah.
One of my friends made something relatively similar to the fur.
Oh, okay.
With Arduino, he made in FabLab,
Mhm.
in internship with FabLab. So he made a lot of laser printed boxes,
Mhm.
and all of them had different modules. Like one had sensors.
So basically, Arduino daughter boards that were.
No, he made the sensors himself, and just one box had Arduino and magnets on the side, so you just click them.
Oh, right.
together,
Okay.
and you
Sure.
could
Yeah.
click a lot of them together. And
Nice. Yeah, there's a project like that was done a long time ago in Japan with cubes, and each of the cubes had magnets on them. Actually, I think they had physical snap connectors because the magnets weren't quite strong enough. And then different cubes had different things. So one cube was a USB connector, so you plugged that to your PC, and then you had a motion sensor, you had a display, distance sensor, things like that. And so you could basically, it became like kind of smart Legos. You could plug them all together and build objects and do things with them as well.
Yeah, you did the same kind of thing, and
Um,
the production costs were really cheap because it was for Fab Lab. So
yeah.
basically, in Fab Lab you just produce blueprints, and everybody in every Fab Lab can create it with
Mhm.
the materials they have.
That's cool. So presumably his designs are open source somewhere in there. Yeah, that's great.
I can see it.
Yeah, that's interesting.
I was trying here yesterday to compile the OSG HIT
Right.
library.
You had some trouble?
It didn't seem to have that much documentation on how to build it. On the, I managed to build the AR toolkit part, but I guess yeah, the OSG.
There's some compiled libraries. I think on the Learn website, don't they have binaries as well as source code?
It could be. I didn't check actually.
Yeah, so go to the Learn site and look under Resources.
Okay.
Tab, and I think there's some compiled libraries there.
Okay.
So you don't necessarily have to build the whole library. You just have to
Okay.
link in the compiled libraries.
Okay, I'll take it.
Yeah, and then if you have trouble, let me know, and
Yeah, I guess I could
we can
speak
talk to Gunn as well because he's a good developer with the OSGRT.
Yeah, maybe Julian as well.
Yeah, Julian would be good as well.
Yeah.
Yeah, so that's for sure. So it's the head map turns off by itself, so it's not working.
What book am I looking for? Well, it's not in here. Oh, Jack the Time Traveler. I haven't read this before. I want to read it.
Okay.
What does the trigger do?
Nothing right now, but yeah.
Entering main loop on the thing. So it's not use this.
No, you just look on the screen.
Camera.
Yeah, you have to use the camera. You don't look on the display. The display's yeah. What have you got to show me?
If it works,
Oh,
you
it's
fancy website, so it's a bit hard to navigate. He made all these little boxes.
Oh, okay. Oh, that's cool.
Oh, that's cool.
Yeah, that.
Did he just shoot them?
Yeah, okay. That's really nice. And so, because they've got the engraved on the outside, this is what they do.
Yeah.
That's really nice.
Yeah, I think it's a bit of like. Oh, that is so cool.
Yeah, this is about the same as the, about the same size as the tangible cubes done in Japan. The challenge was that you want really small bricks sometimes, and because this,
Yeah, this is really for use in Fab Lab, so people can quickly see what sensors will do.
Yeah.
And then start making it with real electronics.
Yeah.
I made a presentation about it.
Oh, that's cool.
I like it. Nothing on the last page. Alright, so
There's a keyboard there. You have to push the keyboard. Yeah.
well, I can send you
Yeah, that'd be great. Send me a link. That's interesting. I could include that with the slides later on. So yeah, that's great.
I'll point out. It even looks like you. I got a blue spot in my eyes standing in front of the beamer.
Oh no.
Which robot is that? Do we have names on them at all?
Do we have what?
This is
Robots?
Futures.
Oh, I don't know.
Christoph probably knows.
Yeah.
It says in the back. Futures.
Oh, okay. There you go. Yeah. Okay, so let's get started again. Don't want to cut into you guys' lunchtime. Seems like had a bit of delay getting started with the other stuff. So what I want to talk about briefly now is, we won't have time to finish it, is Open Frameworks library. Have any of you used Open Frameworks before? You've used before, but you guys haven't before. Okay. So Open Frameworks is a software framework that is, in some cases, a bit more powerful than processing. I'm not sure what your impressions are of frameworks.
Yeah, definitely. Yeah, open frameworks. There seem to be some more options.
Yeah, so it's basically, the idea was developed by Zachary Liebman, Theo Watson, and Arturo Castro. But the idea was they were at a design school in New York, and they were trying to build some interactive media pieces. And they were kind of frustrated because what they found was that they could do interesting work by combining together multiple libraries that already existed. So you could, like if you're doing some augmented reality, you take the AI Toolkit tracking library, combine it with a 3D graphics library, combine it with an audio library and something else. But the problem was that each of those libraries had different APIs, and it became quite complicated to get them all working together. So their idea was that you could have this kind of middle layer overarching API that talked to all the libraries but had the same common user interface that made it very easy for people to build applications. And so that's what they made. They made Open Frameworks. And it's, it runs on Mac, Windows, or Linux, actually also on the iPhone and Android, I think is in development. I don't think Android's quite finished yet. But it makes it very, very easy to build projects that run across the different platforms. So here's the basic idea, is that you want to be able to use the tool or developer kit to combine media and hardware and communications all together in one framework. And so one reason why you might use Open Frameworks instead of processing is that because it's C++ and it runs native code, it runs faster. You get access to lower level information. Also, if you have a programming background, you can use existing debuggers like Xcode or Visual Studio to use it. It's also cross-platform as well, and yeah. So here's a little comparison about why you might want to use one versus the other. So if the project is going to be made available on the internet through a browser, then processing is probably the best bet. If you have a project with lots of 3D graphics, then you probably want to use Open Frameworks because the graphics support is better. If you want to have a project that runs on lots of different computers, then processing could be a good choice for that. Projects using external libraries like OpenCVs, a computer vision library, then probably Open Frameworks. And a project that interfaces with an Arduino board, either will work fine in that case. So the advantages, it's very easy to use, open source, interactive. The disadvantages, it's the software platform is experimental and it's always being developed, so it's not complete, so it has some pros and cons there. So here's some of the base libraries that are supported. So it runs on top of OpenGL for graphics. It uses RT Audio for audio in and out, free type for fonts, free image for image input and output, QuickTime for video playing and grabbing video. And then it tries to combine them all together like this. So the basic idea is that you have these base libraries here that all have their own API, like OpenGL has its own API and GLUT and all these type of things. And then you have this Open Frameworks layer here. And the program itself is basically made up of these three parts. You have a main application, a test app header, and a test app CPP. And the test app CPP is where you put all your code. So it becomes very, very easy to develop. So let me show you, let me scroll down here a little bit. Oh yeah, I'll just show you a couple more slides and I'll show you some examples of code. Actually, what I should do first of all is show you the website. So here's the Open Frameworks website, openframeworks.cc, and you can download the SDK from here. You can get tutorials, the big community, and documentation. The other piece about Open Frameworks that we'll talk about more is that Open Frameworks has a lot of support for add-on libraries as well. So you take the basic framework and then you plug into that whatever other libraries you want. And so there's a separate website called Open Frameworks Add-ons that has all these other libraries too. And there's quite a few of them. So here's a few here. So we can scroll down. So let me say, so maybe we're interested in computer vision. So here's all the computer vision libraries that you can have. So for example, there's actually 3 versions of the AI Toolkit library for Open Frameworks. There's a blob tracker, a basic OpenCV, contour finder, face tracker. There's a few for using Connect. There's the depth camera here for Connect, another skeleton tracker. So there's all that. Then there's graphics libraries, so things that can use rendering skeletons or doing blurring effects, stereograms, for example. They have all this stuff which is really useful. Graphical user interface, another 53 libraries there, so you've got lots of different user interface SDKs you can plug in for doing hardware interfacing, so for talking to robots or your Canon camera, for example. So you can imagine in the physics libraries, sound libraries, type libraries, a whole bunch of camera capture libraries, networking libraries. There's also, or maybe I'll skip through it, there's also a section on iOS libraries as well. So, so this is the basic structure here, and then when you install it, you set up this installation here. And then in the add-ons or the examples directories, where you start building your own application. So when you do the installation, this is what the tree structure looks like. So you have this root directory, you've got your My Project directory, and then you start building stuff in the project folder. Right, so there's installation. Right, so let me show you an example running on my Mac here, and then you can see how it works. So here's my Open Frameworks installation, which I've got two. So I'll use the W06, not the iPhone. And so here's I'll just make this a bit smaller. Some example apps. So let's see. So what examples do we have here? A simple example somewhere. Ah, okay, so here we go. Right, so this one here, for example. So just going to open this up in the Xcode environment, and then in the source, there's really three libraries here, as I said before. And as a programmer, all you have to be concerned about is this testapp.cpp. So there's the code for that. Let me just run that so you can see.
What does the main do?
The main does something, but you don't modify that. Main is used by Open Frameworks library to run the whole program. So basically, when you start the program, it launches main, and then main opens your test apps class and runs everything. So you don't mess with main, basically. So here's a little polygon example. So what they're doing here is they're showing different ways of drawing different polygons. So here's a dynamic shape based on my mouse position. This is using things here. I think you can drag these around. Yeah, you can drag stuff around here. So that's kind of cool. I don't know if you can drag those, probably not, because I can't catch them. So anyway, so it's just a little demo app showing how you can run multiple different polygons on here as well. Let me go back to the PowerPoint presentation. Okay. So this is a recipe, and so of course when you make a recipe, you've got to separate between your ingredients and your method for doing that. And that's pretty much what Open Frameworks does, is it basically has a separation between data types and variables and directions or algorithms. So in the test app.h, it's a header file, and here you're supposed to put all your variables, and here you're supposed to put the definitions for the functions that the variables use. Sure, yeah. So everybody has a main function, but unlike processing, the main function is hidden, but in Open Frameworks it makes the main function available, so you can modify it if you want to. So So here's your main function, and all it's doing here is it's just opening up a window, and then it's running this new test app. So all it does is it creates a new class and runs it. So it's very, very simple, and it just runs that application class until it quits. The test app is where you actually declare what the class is going to do. So in this case, there's a simple case. They're just going to capture key presses and mouse drag events. And here's the basic empty test app. So you have four, in this case, four methods. One that's called on setup, one that's called to update every frame, and one that draws the output, and one that responds to key presses. So the typical functions are setup functions that load assets and initialize values, update functions that perform some calculations, and drawing functions that draw the output. And you've got a range of different 2D functions. You can also do 3D functions. So let me show you the Hello World app, and you can see how that works in a little more detail. Oh, I don't have a Hello World app, but I have an empty sample app. Yeah, here we go. It's not helpful. Let's close this. I clicked the wrong thing. I need to click on that. Probably stop this guy running. So here's the example, the empty example. So as I said before, you just open a window and then it just creates a new class and runs the class, the test app class. In the header file, this is the default methods in the header file. And the test app, it just has a bunch of empty functions. And then you can write your own code in these functions when you want to do different things. So to here. So let me show you a couple of demos of what can be done with open frameworks, so you get an idea. So here's a simple example graphics demo. So you can draw a circle, draws rectangles, draws transfer, draws lines. If I push S, it makes the lines aliased or anti-aliased. Show good so well on the projector, but when it's quite smooth on my laptop, but not there. There's some transparency there. So let's look at the source code for this, and we can see how they do that. So again, you have nothing. You don't change the main application at all. In the test app header, all they've done here is they've added a couple of they've added a flag here, a Boolean flag, to say whether it's smooth or not, and they're a little counter as well. And the actual code here is where they do most of the work. So because they're including the go back to here, the OF main header, there's a lot of default graphics calls that you can do with open frameworks. So in this case, on the setup, we draw, initialize a circle and set the title of the window, set the frame rate, and then we have this counter that's running all the time that modifies the circle width. And then here's the code for drawing those different pieces. And we don't have any events here except for the key pressed events. When you hit the S key, it toggles between smooth and not smooth. You can see it's pretty straightforward. You've got this code here which draws a circle, and then draws an outline around the circle, and then sets the bitmap string to draw the text of the circle. You've got the second piece of code here that draws two rectangles. Well, actually, lots of rectangles that are all on top of each other. You've got this third piece of code that does the transparency, and the fourth piece of code that does the red lines. So You get things like OF line, that lets you draw lines between points and so forth. So if I go back to the application, which is running, where is it running? It's running here. You can see it's just has 4 parts to the draw function, 1 for each of these pieces here. It's very, 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 very simple. Sure. So here's the test app header file. So all these ones here you get by default, and all actually it's the wrong header file. This is the header file. You get all these by default, and then all they've done here is that because they want to use a global variable to store the counter and the smoothing state, they've just added these 2 here. And then you don't modify the main at all, and then you just define in the test application what you're doing here. Does that kind of make sense? Now the cool thing is with this that it will run on, so the polygon example I showed you before, which is still, that one. Here's the polygon example. Here we go. So the polygon example here, this will run unchanged on the on your iPhone as well, just by recompiling for the iPhone. So in the 06 download, you've got all this code that runs on 06, but then you can also, you've got the iPhone version as well. And if we go and look at the iPhone examples, and we can pull up here the graphics example, then if you look at this, the code will be exactly the same. And the nice thing is that normally if you program for the iPhone, you have to learn Objective-C and you've got to reprogram with a different language. But because the Open Framework sits on top of all that, it provides a C++ interface into the iPhone as well, which makes it much easier for you. No, Objective-C is not. It's very different. Yeah. So it came out of Next when Steve Jobs sold Next to Apple. So there are some elements that are the same, but there are some things that are very different. And so here's the same code for the iPhone. So again, the header file looks exactly the same. You have to include, well, there are some changes. So you have to include the header files relative to the iPhone, but it's quite simple. And then here's the code here, and you can see that it's pretty much the same code. There's they've modified it now, so instead of having to hit the S key, because you don't have an S on the iPhone, well, you don't want to pull a keyboard up, they've modified it so it's a touch event, so you just touch the screen and it turns on and off. And then they have the same 4 chunks of code, so drawing a circle here, filling the rectangles, and the transparency and drawing the lines. I'm not sure. I think in Touchdown it returns a touch event and it returns the location of touch event. So you can have multi-touch because you have multiple touch events. But yeah, I'm not sure. So on my iPhone here, let me show you some example apps. But actually, I should have got it running on the iPad, but I was too lazy. Let's see. Oh, I don't have the simple graphics demo. I do have though as the polygon demo, so I'll pass it around. But you can see here running on here is the exact same demo that's running on the iOS. I mean the OS X screen there, and you can put your finger on the screen and drag your finger up and down, and you'll see the width of the things. So I can see. Try for yourself. So that makes it really powerful because you can basically build application on the PC or on the Mac, and then you can port it across to the handheld device with very little work as well. Well, I think the Android is still in beta stage. I'm not quite sure how far along they are with the Android. They're definitely working on it, but Yeah. So let's go back to my slides here. Yeah, I want to skip forward a little bit and talk about. Okay, so I guess I mentioned about the libraries, about how there's a large set of Open Frameworks libraries, more than 450. And so all you need to do is you need to just include the library in your add-ons directory and then add an include file for including the library there. So here's some sample libraries. I've got the OpenCV, Vector Graphics, Vector Math, a networking library, the OSC controller. So in my well, here's the list of libraries here I showed you before, but in my directory structure here, you can see, let's not look at the iPhone, let's look at the Mac version. Here's the add-ons here, and so, for example, here's a 3D model loader, so you can load 3D models. Here's the OpenCV, and then if I go to the example apps, and here's running the 3D model loader running, so it's loaded up a little model of a squirrel. And I think I can. No, I thought I could change the rendering style. I guess not. Yeah, so that's the 3D model loader going there. And they have another quite cool example is the OpenCV. So OpenCV takes input from the camera. There's my face, and then it's doing thresholding, and it's doing blob detection here as well. And actually this same example will run on, let's see, is it here? No, I had, oh, here we go. Here maybe? Oh, it's an artifact of the video, I think. Let me see here. Well, I can show. So here's another example of OpenCV running now on the iPhone. So you can take the same example and get it running on the iPhone, and now you've got access to the iPhone camera, and this one does blob detection. Yes, I can. Let's see, threshold, push the plus minus, so yeah, so sure. Now the threshold's going up, and you see it's getting darker, darker. I can push the threshold down. Yeah. Well, the blob detection's probably messed up because of these lines, streak of lines across here, but I think there's an artifact on the camera, if I don't know. Yeah. So anyway, that's OpenCV running as well. So I think you touch the screen and you move. I can't remember how it works on the iPhone, but so basically what you do is you download whichever. You can go to the OFX website, add-ons website. You download whichever add-on you're interested in. You put it into your add-ons directory here, and most of the add-ons have an example app showing how the add-on is used, and then you can do that. Yeah, and again, it's if you load up the project file, then it's very simple. So we still have the same three. This is the code for the 3D model loader. We still have the same three applications here, but now it's a bit more complicated because we have to do some more work. So in this case, in the test app, when we call a setup, we have to call a bunch of code to do the OpenGL enabling and modeling, and then we've got this load model function here which loads the 3D Studio model in, and then we have this draw function here which has basic OpenGL commands in the draw function here. No, doesn't. But you could have a touch event, and I could set it up as well. Yeah, it's true. Yeah. So here's, I've shown this example already. You can, in a similar way to what you do with processing, you can create your own shapes by bracketing them by begin and end shapes. So here's a shape using vertices for beginning and ending shapes. And there's the following example. There's a box demo, so you can do 3D graphics as well. You can also do OpenGL in the Open Frameworks code itself. And I just showed you an example of that too. Let me see if I can get this running also. It's the advanced 3D example, of course. So in this case, it loads up a scene with a lot of balls moving around. There's a light source moving around with multiple cameras here, and you can zoom and rotate the coordinate frame as well. You can change the camera, the orthographic camera on the side, what it's attached to, and you can also toggle full screen. Not. You can switch camera views around here as well. It's more, and the code for that, again, is fairly straightforward. So this one's a little bit interesting because they've actually introduced some more example classes as well, because they wanted to have a separate class for drawing the grid and drawing the camera and drawing the swarm of objects. So you still have that basic test app class. In this case, you've got the header file, and in the header file they've introduced some other classes for the orthographic camera and for the swarm and the grid they're drawing. And then in the test app, again, you've got this same setup code here, the viewports and the drawing code. The drawing code uses OpenGL for drawing, so here's the OpenGL commands to set it up. And then you have this draw scene function, which divides up all the viewports. And there's a camera drawer that draws the cameras, and the key press for responding to the key presses and so forth. So it's very, very straightforward. So we're about out of time, so I'll stop there, and next week, well, not next week, in 3 weeks' time, we'll talk about Open Frameworks a little more, but we'll also start talking about 3D printing and how to build physical prototypes. But the takeaway message from this, I guess, is that if you're prototyping more complicated objects interactions, then you may want to use Open Frameworks because of the large amount of support for different add-on libraries as well. Like if you want to do a project with the Connect that does skeleton tracking, then putting it together in Open Frameworks would be much, much simpler than processing, and also much more powerful. Yes, I think so. Yes, I think it does for sure. Yeah, definitely. Yeah, definitely. Sure. Yeah. Yep. Just scratching my head too. I've been doing a lot more Objective-C programming, C++ lately, but yeah, definitely. So, do you have any questions about what we talked about today? And you've got your assignment, so you can start thinking about that. If you've got questions about the assignment, let me know, and I'll be around the next few weeks anyway. Great. Well, let's stop there, and then if I can find my Camtasia, I'll